Okay, this is Monday, June 25th. We're here at the ASHRAE annual meeting here in San Diego. I'm Bruce Johnson, member of the host committee and also a member of the historical committee, and it's my honor and pleasure to interview Mr. Ole Fanger. Did I say that right?
Yes, Ole Fanger.
And what we'd like to find out is more about your background for the record, and you're on tape right now, videotape. And we'd like to hear from you, like where you're from, some of your family background, and some of your growing up period to start out with.
Okay, thank you very much. Well, I'm Danish. I grew up in Copenhagen in Denmark and took an engineering education there, and specializing in heating and ventilation, air conditioning. And then I continued at the university as an instructor and studying literature. Then I came gradually more and more into the fundamentals of why we are ventilating and heating and cooling our buildings and our vehicles. And I thought there was so meager information on the basics on human comfort and human responses to the environment. So I started looking into that in the literature, and I got then fascinated by what was happening here in ASHRAE. At that time they had a climatic chamber where they could study human beings and exposed to all kinds of indoor environments. And that was moved from Cleveland to Kansas State University, and that was announced in the ASHRAE Journal, and I got very eager and got a grant to go over here and worked for in 1966-67. And at that time they had a very fine team of researchers. Ralph Nevins and Preston McNall and Fred Rolls was there, and well, they were setting up huge studies where they studied thousands of human subjects and how they reacted physiological and psychological to the environment they were exposed to. And I had the opportunity to participate in these studies, and it all resulted in in setting up a model where you could predict. That's of course always any dream is to predict things before they happen, and we got for the first time a model where you can predict human responses in ventilated and heated and cool spaces as a function of people's activity and their clothing and radiation. You had velocity and humidity. And so when I came home, that became my doctoral thesis, and there was a defense for that in Copenhagen at the university, with Press McNall came over and was one of the judges, and another was Pharaoh Gaki, that just the other day here was elevated to the Hall of Fame or ASHRAE. So he was a giant inside and a mentor for me, together with Press McNall. So that was a very good start, and then we came home. I came home to Denmark, and we set up climatic chambers and continued our studies on of the environment, the impact of the environment on human beings, based on what we found was required for the practical engineers. So that's the whole thermal part of it, and then gradually, parallel with that, there came the standards work. Standards in ASHRAE, where I participated in. I came often to the States afterwards to ASHRAE meetings. I think I've been participating in 45 meetings or something like that since then. So I have followed very closely ASHRAE and all the things happening over here. We've had a close collaboration between our lab in Denmark and laboratories here in the States, and many researchers here. And that was...
You pioneered the early research that went into the comfort chart that we have now in the ASHRAE handbook. Is that part of your effort, or?
Well, others will have to judge
Others.
who are the pioneers and so forth, but sure, we have made our contribution to the handbook and to the standards and the ASHRAE standards, and also there's an international standard that came in 1984, which is quite similar to the ASHRAE standard, and where we also made our contribution in terms of predicting human comfort, and also an important part was the predicting when people are feeling a draft. We found one thing that was very fascinating. That was that people were found not only air movement, but fluctuating air movement was particularly unpleasant. People don't like turbulence or things that variates. All our senses are geared to give signals to the brain when something is changing. So if you have changing velocity, whether you're in a hotel room or in an airplane or whatever, it bothers people in particular much. And that we found a new model for draft, and that model is included in the ISO standard now, and in the international and in ASHRAE, in the German and so forth all over the world. So that's the thermal part of it.
You know, humidity is a little more subtle effect on comfort. People say it's stuffy or too warm in here, and they're really saying the humidity is high, or if it's too low, you get another effect that's not desirable.
Sure, that's...
How did you address that? And just by varying humidity on test subjects?
That's again, you have to expose subjects to the, and not only a few, but really hundreds to get the statistics all right. So you can say, here we put the limits, and there are only very few who are bothered by it. So that's the...
How did you select subjects? I know the handbook used to list the difference between, age groups, metabolism, gender, even economic status was part of it that went into the comfort range. Did you get into that
Sure,
deeply?
we had different groups in Copenhagen, and they also continued studies at Kansas State and at Pierce at the Yale University, where we have parallel studies, and we have studied elderly persons and very young persons and people from the tropics, and just after they came to Copenhagen to see adaptation and so forth.
Different racial groups and
even
so
different
forth.
racial groups, and it's surprising to see how small the differences are among these groups, but there are huge individual differences, of course. That's we knew that already, so that's the...
Even the rule of thumb seemed to be that, what, if 80% of the people in the building aren't complaining, or if only 20% are complaining, you're okay, or how does that, you've heard of that, no doubt.
Sure, that has been the aim to have a modest, or the substantial majority, as it's expressed in the standard, should be comfortable. That's when people are exposed to the same. Of course, in the long run, I think we are moving in that direction, that you have individual climates, or even when you are in the same room, you can have workstations where you can turn in the climate that you exactly want at your workstation in your office. So, like you're not wearing the same number of shoes, you have difference. That helps a lot for the comfort of footwear, and that's the same with also the climates. Individual control, I think that's a great future for that.
Did you find indoor air quality or even odors might contribute somewhat to the feeling of comfort? Was that something you had to address in your studies?
Well, this is then the other line that started where the thermal comfort, I had my book was published already in 1970 and republished several times in McGraw-Hill and so forth. That was the thermal comfort part of it. And then in the late 70s or early 80s, we started with intensive indoor air quality studies, where the idea was to find out fundamentally what is fresh air and what is it that bothers people in many places in the indoor environment. Why are so many buildings where all standards are met still unpleasant and stuffy, and you have all the complaints of headaches and irritation and so forth. That was a big frustration and is still a large, a great frustration for the engineering profession. That although all standards are fulfilled, there can be quite many people who are complaining. That all field studies show that. So there's still a good deal that we don't know, but we started exposing people to not only, there was a long history in this again that is quite fascinating to study, that for more than 200 years the philosophy in ventilation theory and thinking has been that people are the only sources of pollution in normal spaces and homes and theaters, offices and so forth. First it was believed that people were exhaling for more than 100 years, that they were exhaling poison, simply poison. It was deadly poisonous for other people to inhale what has been exhaled by others. First it was believed it was CO2, and that was up to the late 1800s. Then it was believed there was a special material that you exhale called anthropotoxin that was highly toxic to people. That was the French that came with this theory. And it was never demonstrated chemically that there was any substance. So finally, in the early 1900s, then there was a change, the paradigm shift, a great paradigm shift. It's interesting to see that from the early 1900s, there was it was contagion. It was the transfer of disease from one person to the other that should be decreased by generous ventilation. And there was a Mr. Billings in ASHRAE, a medical doctor, who proposed very high ventilation rates to decrease the rate. So that was the next 30, 40 years we were ventilating to avoid transfer of disease from one person to the other, tuberculosis or common colds or flus or whatever. Then in 1930s, Yaklu came in. Yaklu, he was the big name at Harvard University. They made large studies, and now it was comfort. But again, it was assumed that people were polluting the air and nothing else. And he made his classical studies at Harvard, paid by ASHRAE. And we have all studied these papers, you know, for every single detail in those. And we then repeated them in Copenhagen, and there were similar studies at Yale University at Pierce, and also Japanese studies, and they showed very similar an updating simply of the old studies, so Yaklu. But the big new thing that was found was that there were, which was really quite obvious, but it had been ignored before, that there were many other things that contributed to pollute the air. Furnishing, building materials, office machines and so forth, all the thousands of building materials that had come in, and even HVAC systems. So that was the new development. And we had the first time we arranged in Copenhagen with many important ASHRAE members, the first international indoor air conference in 1978. With key persons here from ASHRAE and United States, and these type of conferences has then gone on every third year. Recently there was one in Finland with 1,400 participants, and so the whole indoor air subject has been taken up by ASHRAE and others, and we then modeled and introduced new units. Old unit and decibel unit, which was units for perceived air quality. We said we have to acknowledge that we have many other materials that bothers people and irritates them, and provides odors, so the air, and ruins the freshness of the air. And this is what we have been working with since then, to model the whole thing. Again, predicting air quality before the building is built, so we can avoid all the dirty materials and things that, carpets, whatever,
It's interesting, your comment, the equipment contributing to the problem, like the Legionella problem here in this country, and I'm sure in Europe you have something similar, the growth of microorganisms in water towers and maybe even on filter mats or spray coils.
Right.
And then here the tobacco smoke problem, we're almost in a hysterical mode on that, and I don't know that other countries share that. Is there a similar concern in your country and over smoking in office buildings and similar things?
Sure, but I think maybe in many respects North America is leading the way in terms of the tobacco smoke, and maybe it's more frequent here with ban of tobacco smoking and so forth. But on the other hand, there's been the last ASHRAE standard 62, for instance, allows tobacco smoking without any penalty in smoking, and I think that's now being changed, and that was an obvious error made in, everybody can see that now. Of course, tobacco smoke contributes to, everybody knows that.
Years ago, the old standard was, what, 7.5 CFM per person, but if you're smoking or in a conference room, it went up to 15, and now what the allowable is 20 CFM minimum, or somewhere, I'm talking English units, of course.
Right, okay. Well, that's, all the evidence we have is that tobacco contributes much more, and there's been extensive studies at Yale University and at our university in Japan and so forth that we have to acknowledge that if tobacco smoke, if there's environmental tobacco smoke, then we have to add some more ventilation. Every child knows that, so we better get it into the standard again, and that's what happens now. I'm a member of the ASHRAE 62 standard committee, and I've been for several of the earlier committees also, and of the European, there's a European committee too,
So you're at a university, I see, and are you in a teaching mode there, or more research, or what are your activities mainly right now?
Well, we have we have some teaching, but it's mainly research. We have quite an international group with people from many countries in our research group, and it's sponsored by European Union, and also we have done a number of ASHRAE-sponsored studies at the Technical University of Denmark in Copenhagen. So,
can you make any predictions on where this is all leading us? What do you think the next decade or so will bring?
I think we will see substantial changes in the components, the way we are making ventilation systems. All the components have to be checked, first of all, that they are not sources of pollution, filters and rotating heat exchangers, whatever you have. They should, if anything, improve air quality, not degrade that it sometimes does today. So we'll have to consider it's not just a question of supplying air at a certain quantity. We have to be very careful how we treat it. It's a very easily, you can destroy air very easily. It should really be handled with love and care, fresh air.
California, you may be familiar with what we call Title 24, which is really an energy conservation code, but it did adopt a lot of ASHRAE's recommendations on ventilation standards. You see the need for more regulation, government involvement? I mean, are you involved in that end too, in getting legislative processes through?
Well, I think in what will drive it, I think the market will drive it. There's a strong interest in, at least in Europe, and I know also here from many building owners, even the larger automobile makers have the same thing in the cars, of course, that they're ready to pay to get a higher quality, but they don't want to pay and get low quality. And you can it's not necessarily that you get, there's a lot of know-how that should be applied, and we still, for instance, we are now developing databases on building materials, on pollution sources, so architects and others can select low polluting materials. But I see the development like we had in the beginning in large cities. We had 25 or 50 years, we had a lot of pollution, more pollution outside. I guess it's the same in California here, that fortunately due to source control, reduction of the sources, we are getting an easier opportunity to get better air quality. We will see the same tendency. We have to care much more about what we are putting into our buildings and the systems. We have to care very much how we treat the air. So filtering technology will need to be improved so you can filter the gases, which you perceive the gases. The particles are not so important for the perception. So the freshness that you can feel out in when it's best outdoors, that's what we would like to recreate indoors. And that's difficult today. It's a real challenge for us in the future. So, and many are interested from a comfort point of view, of course, that everybody would like to perceive the fresh mountain air, or sea air, or whatever, when it's best outdoors.
Now, I remember reading the article in the journal a few years ago, and I was very intrigued by it, kind of a different approach to what you call the Old Fiona. Would you mind going into that, giving us some background on that?
Well, that was, as I said before, after 200 years where all ventilation theory and thinking had been emphasizing that people were the only polluters, and there was a lot of data then on how much should be ventilated to handle the pollution from people. What we found out was that many other materials are polluting, and therefore the very simple approach was then to say, why don't we express all other sources, tobacco smoke and building materials and so forth, in terms of equivalent persons. How many equivalent persons would be required to pollute equally much as that carpet, for instance. And of course, it's very complicated in chemical terms because it's very low emissions, and even bioeffluents from human beings. We're speaking about hundreds or thousands of chemicals in very small concentrations, but enough to bother people. The same with the carpet. It's not one chemical, but often hundreds of them. So we said, 1 is simply one equivalent standard person. And of course we had a lot of information on what was required to ventilate the persons, and then we just said there are that many persons in a room, and then the rest of the room, the empty room, was polluting, for instance, 20 corresponding to 20 persons. That was, and how should we measure that? Well, we should measure it with human beings. That's still with panels. Jaakko used that at Harvard, and that has been the way we have been testing the air quality and the sensory, the perceived air quality. Of course, there are health aspects also, which are equally important, but normally what has been driving all ventilation standards has been the perceived air quality, the comfort aspect of it. So it's just to, and this unit has then gone into, we can measure that with panels still and do systematic studies where we measure chemically on all kinds of building materials, for instance, chemically and then sensory with panels. Because the latest interesting aspect is that the electronic nose, where you have a lot of different sensors, and you simulate the human nose in a way, so that it's a very interesting development. So instead of having panels going around, that's what we have been doing with panels. They go around in 100 buildings in Europe, for instance. We've had panels coming into the rooms and judging the air quality according to certain scales. Then we can calculate, when we know the ventilation, we can calculate the source strength of the empty room. It's often most important to come to the empty room, so to see how much the building in itself contributes. And even studying the air quality coming out of the out from the system to see how much it may be polluted even before it comes into the room. So that's another. When we really go for air quality, not just air quantity. That's the important thing. So that's now in European guidelines for ventilation requirements, and it's also coming into a European pre-standard. So the again modeling. These units are important. It's in a way like the units we have decibel for and watts for sound, and lumen and lux for light. These ALF and the deviated unit is decibel. That's for perceived air quality. ALF is for the source strength.
So part of your interest or work then is going into existing buildings that have problems and doing a review or investigation to find out what's causing the problem and then removing it or figuring out a way out to, I know I've seen some of that where they had a printing room or something without exhausting it, you know, and there's a whole series of equipment giving off fumes, and nobody gave a thought to putting in an exhaust system and separate from ventilation. Is that typical you find those things?
Well, that's our studies, our research is partly in, let's say, in the lab where we have everything well controlled, and then it's partly out in the field in real buildings to validate the lab studies. So, and that has really been fascinating, and the collaboration with ASHRAE and all the technical committees here, and it's just been a fantastic development. And from the first time I came in '66 with all the thermal aspects and all the enthusiasm that stroked me from the first minute I participated in the ASHRAE activities. And so that was very encouraging, always encouragement inside ASHRAE. That's been unique.
Industrial or commercial end of it a little bit too? Is that part of your interest?
Sure, we have collaboration with industrial firms also in the US and in Europe and so forth, and even air quality and automobiles and so forth. That's, so we have a wide net of collaboration. That's on the that's all on the scientific side of it, and of course then ASHRAE has been very generous in all aspects of taking in me and many others from outside. That's again the development of ASHRAE from, let's say, a more in the beginning, or 30 years ago, from more a North American society to ASHRAE's international, widening up to ASHRAE's now much more international approach. I think I've been a little bit contributed maybe a little bit to that.
Well, I notice you have the F. Paul Anderson Award. Can you tell us a little bit about that? What?
Well, that's of course a very great honor because this is the highest award for accomplishments or scientific or other accomplishments that ASHRAE has. So it was very generous that ASHRAE selected me as the awarded in 1992, I think, as the first non-American recipient. So that was...
And it's apparently not awarded every year either. It looks like there's gaps here in the award process. Maybe every 5 years they find somebody.
Oh, I think that's recently it's, well, I haven't seen the whole record, but it's way back from 1930. Paul Anderson was a really a key person and a pioneer in comfort research, by the way. Also at Kentucky University, I started his career. So.
In addition to that, you also have the Louise and Bill Holladay Award.
Sure.
Tell us about that, please.
Well, that was already in 1982 for that. Bill Holladay was a very important person and is still in ASHRAE, and he decided to, together with his lovely wife, they decided to establish this medal especially for fellows who had provided special accomplishments, and I think that was in 80 or so. So I was very privileged to receive that medal as well.
Well, you've had a very impressive career. Would you recommend anyone to follow in your footsteps as an engineer and researcher? What recommendations could you give a young fellow today?
Well, I think there are great opportunities still in our field, and the whole consciousness and interest for the environment, ASHRAE and other societies similar to that in the world, in the HVAC and our world, they have a great possibility to step in and take advantage of the public interest, and I think there is great possibilities, and of course also great possibilities in the industry, but they should really be they can't just do things as they've done previously. They must be out on the edge of the development, and there's a lot to do, many exciting things in the environment due to human requirements. Everything starts with human requirements, and people are ready to pay and ask for much better environments, also indoors, where they spend 90% of their time, as we know. So that's an international thing. It's not only ASHRAE, it's global, and I think that has been a tremendous development we have seen there in collaboration. I think when I first came over, and that was the international part of it, I think. I was invited in 1974 when there was first established a kind of international policy in ASHRAE. Part of it was to have a few advisors coming over and participate in key committees, in the R&T committee. And I noticed that was very little information on what happened in other parts of the world. The same, I was involved in REVA, the European HVAC and R collaboration between societies. There was also not too much information on the American scene, so I've tried at that time to get people together in the two parts of the world, and after a number of years it became ASHRAE. It became a routine, which it is now, that ASHRAE president come to REVA's, the European meetings, and we established in Copenhagen the first World Congress on HVAC and R in 1985, where ASHRAE was a very important partner. The first World Congress in our history, so we were pretty proud of that. And since then, there's also been more and more internationalization, and ASHRAE have now, I think, some 35 associate societies, and it's a routine now that many foreigners or non-Americans participate in the meetings, contribute with papers, and that's been a tremendous advantage for all of us. And but still, I think, and it has been a great inspiration for all, let's say, similar societies to ASHRAE in other countries. It's been a great inspiration to see how ASHRAE was organized and the encouragement and the way that members become active, and our ASHRAE get all the thousands of members 2 times a year to come and work 5 days. 5 days in all the hundreds of committees. That's a goal, and for all other societies, and so they really envy ASHRAE, this excellent organization, and everybody try to learn and copy, just on a much lower, to a much lower extent. But that's
Well, thank you very
fascinating.
much. Thank you for coming, sharing your time and experiences with us. It's been a real pleasure.
Thank you very much. Pleasure.